Alkene and alkyne names are derived from the names of the alkanes of the same carbon chain length. The same prefixes are used, like meth, eth, prop, etc. Except we change the suffix. What was once -ane becomes -ine for an alkene and becomes -yne for an alkyne. To determine the name of the alkene or alkyne using the IUPAC nomenclature system, we follow a few simple rules. First, we count the number of carbon atoms in the longest continuous carbon chain containing the double bond for alkenes or containing the triple bond for alkynes. Then you name the alkane with the same number of carbon atoms, and that would be the parent compound. Next, you replace the ending -ane with -ine for an alkene or -yne for an alkyne. Next, we prefix the name with the number of the first multiple bond carbon. So for example, if you had these two alkenes that I've drawn here in blue, you can see that they both have 1, 2, 3, 4 carbons. This one also has 1, 2, 3, 4 carbons. If I have a 4-carbon hydrocarbon that is a straight chain, it would be butane. So these are both butene. But then according to the rule here that I have highlighted in blue, we prefix that name butene with the number of the first multiple bond carbon. And so since the first multiple bond carbon in the one here on the left is 1, this would be 1-butene. And since the first multiple bond carbon in the second one is 2, this would be 2-butene. Lastly, we list our branches or substituents the same way we did for alkanes. So for this alkene, for example, that I have drawn in green, we see the longest carbon chain containing that double bond is 1, 2, 3, 4. This must be a 2-butene, but we also have this methyl group up here. So this would be 2-methyl, 2-butene. This slide just shows some comparison of the names of alkanes, alkenes, and alkynes. If we have a 2-carbon hydrocarbon that is an alkane, it's ethane. If we have a 2-carbon hydrocarbon that's an alkene, we call it ethene. And if it's an alkyne, we call it ethyne. If we have a 3-carbon alkane, of course, we call that propane. If we convert one of those single bonds between the carbons into a double bond to make an alkene, we have propene. And then finally, if we have a triple bond, we would call that propyne. I just showed you that if you have 4 carbons, then you have more possibilities. You could have the double bond on the first carbon like this. So this would be 1-butene. And also you could have the double bond in the middle like this. So this would be 2-butene. And you can imagine that as we add more and more carbons, there become more and more places that we can put that double bond. The same thing also would apply to an alkyne. So if I had a 4-carbon alkyne where the triple bond starts on the first carbon, this would be 1-butyne. And if I had an alkyne where the triple bond starts on the second carbon like this would be 2-butyne. Let's take a look at an example. It says give the IUPAC name of each alkene and alkyne. So we'll start with the alkene A. The first thing we want to do is find the longest carbon chain that contains the double bond, and we want to give the double bond the lowest possible number. So I think it's pretty easy to see that in this one, I should start on the carbon that is on the far left, and I would call this carbon 1, 2, 3, 4. I could go up and number this methyl group as carbon 4, and I would end up with the same name. So we'll just leave the numbering the way that it is. Now you can see that the longest carbon chain that contains that double bond has 4 carbons. So if we have a 4-carbon alkane, it would be butane. So of course, since this is an alkene, it becomes butene. Then I have to prefix butene with the number of the first carbon in the double bond. So this must be a 1-butene. And then of course, I have to list my substituents in alphabetical order. I don't really have to worry about alphabetization too much because there's only one substituent, and it is a methyl group on the 3rd carbon. So this is a 3-methyl. Remember, we separate letters and numbers with hyphens, and so this molecule becomes 3-methyl 1-butene. If I take a look at B, first I want to find the longest carbon chain that contains that triple bond. And for this one, we're going to have to start over on the right with this carbon. So we have 1, 2, 3, 4, 5, 6. There's our longest carbon chain. If I had a 6-carbon straight chain alkane, it would be hexane. So since this is an alkyne, right, we have our triple bond, this must be a hexyne. And then I have to prefix that with the number of the first carbon of the triple bond. So this would be a 2 hexyne. Now I have to identify my substituents. This molecule has one substituent at carbon 4 and it's an ethyl group, so this is a 4-ethyl. Again, I don't really have to stress too much about alphabetization because there's only one substituent. And so this molecule is 4-ethyl 2-hexyne. It might be a good idea to pause the video here and see if you can name either of these molecules. Now let's take a look at the one on the top. You can see that I have a double bond in the molecule. So this is an alkene. I'm going to number the longest carbon chain containing that double bond, and I'm going to number it in such a way that I give that double bond the lowest possible number for the first carbon in the double bond. So I'm going to number it like this: 1, 2, 3, 4, 5, 6, 7, like this. Of course, you could have numbered this as carbon 1 or carbon 2, and you would have ended up with the same name, or you could number this methyl group as carbon 7, and again, you would have ended up with the same name. And so if I had a 7-carbon straight chain alkane, it would be a heptane, and thus this is a heptene, and it is 3-heptene, so let's write that down. We'll put 3-heptene. Now I have to identify my substituents. I have an ethyl group at carbon 3, so this is a 3-ethyl. And I have a methyl group at carbon 6, and thus this is a 6-methyl. Now I have to list those substituents before 3-heptene, and I have to list them in alphabetical order, and E comes before M in the alphabet, and thus this molecule is 3-ethyl 6-methyl 3-heptene. Let's take a look at the alkyne on the bottom. Let's follow the same rules. I'm going to number that longest carbon chain that contains that triple bond, and I want to give it the lowest possible number. Now, something that's interesting about this example is that if you number the longest carbon chain containing that triple bond, if you number it this way that I'm doing in green, either way, you end up with a 3-hexyne. But the problem with the numbering in green is that the methyl group would have a number 5 as its locant, or its number identifier. And so if I use the numbering in red, I'm going to end up with a 2-methyl group, which is preferred over a 5-methyl group. And so the numbering in red is the correct way to number this alkyne. And so this molecule has a methyl group at carbon 2, so this must be 2-methyl 3-hexyne. Alkenes having more than one double bond are called alkadienes, which just means 2 double bonds, or alkatrienes, which just means they would have 3 double bonds. The way that you name them is by determining which double bond is nearest one end of the longest carbon chain containing both or all 3 of the double bonds. Then we number the carbon chain by using the number of the first carbon of each double bond, or using the lowest numbers. Then we use the appropriate suffix, being diene if it's got 2 double bonds, or triene if it has 3 double bonds. You can see that in the first example, 2,4-hexadiene, that we use the numbers 2 and 4 as the locants, or the identifiers for the double bonds, because they are the numbers of the first carbon in each of the double bonds. The same thing applies for 1,4-pentadiene. I use carbon 1 and carbon 4. And the same rules would apply for alkynes as well. Cyclic alkenes are named much like cyclic alkanes in that we prefix the name with cyclo. When we're numbering our double bond, in our cycloalkene, the numbering must start at one end of the double bond and it has to pass through the bond. So therefore, if I just drew cyclohexene over here, so this molecule is cyclohexene, if I were to put a substituent on here, like let's say an isopropyl group like this, the numbering has to start through the double bond. So I have to go 1, 2. The numbering always has to pass through that double bond. And then what we want to do is give the substituents the lowest possible numbers. So we can number the molecule either going clockwise or counterclockwise. Whether it's clockwise or counterclockwise is not important. What's important is that you abide by this rule here, that the substituents have to get the lowest possible numbers. So if I draw the bond line structure of this molecule here, it might be a little bit clearer if I do that. So here's my double bond. I have a chlorine here, which is a chloro, and I have a CH3 here, which is a methyl. Remember, the numbering has to start going through the double bond, and therefore I'm going to start like this. 1, 2, 3, 4, 5, 6. And so this molecule must be 5-chloro-3-methyl cyclohexene. Now I've gone ahead and redrawn the bond line structure on the right over here in black, and you can see that if I was to number going through that double bond, so 1, 2, 3, 4, 5, 6, then my two substituents would have the numbers 4 and 6 as opposed to 5 and 3. And 4 and 6 are higher numbers, and so that would break this rule. That would not give the substituents the lowest possible numbers, and therefore this would be the incorrect way to number that cycloalkene. A way of rephrasing what I just stated is that when naming cycloalkenes, the double bond is going to be located between carbons 1 and 2. So if we take a look at this example over here, 1-methylcyclopentene, again, we start numbering going through that double bond, and we want to give the substituent, and in this molecule there's only one substituent, so what would the lowest possible number be? It would be number 1. And thus the molecule would be 1-methylcyclopentene. The example on the right is much trickier, and this is a trap that students will fall into sometimes. Is you can see that it's numbered correctly here because my numbering goes through the double bond, 1, 2, 3, 4, 5, and then 6. So I have 2 methyl groups, so it's going to be 1,6-dimethylcyclohexene. The trap that students might fall into sometimes is that they might try to number the carbons like this. They'll say 1, 2, 3, and then the rest, of course, 4, 5, and 6. And then they say, okay, it would be a 2-methyl, 3-methyl, so it would be a 2,3-dimethyl. 2 plus 3 is 5, 1 plus 6 is 7, so maybe 2, 3, maybe that's better. No, it has nothing to do with adding up numbers. That is completely incorrect. We abide by this rule here. The ring is numbered so that we give the first substituent the lowest number. Before we move on, I just want to mention that when we're naming haloalkenes, and halo means a halogen, fluorine, chlorine, bromine, or iodine. When I'm naming a haloalkene, the double or triple bond is going to take precedence over the halogen or any alkyl group. For example, if I had this molecule here, we see that the parent or base is named after the 4-carbon chain alkene, which is butene. Of course, we give that double bond the lowest possible number, so it becomes a 2-butene, and so this molecule would be 2-chloro-2-butene. If we take a look at 2-bromo-3-hexyne, this is kind of an interesting example in that the numbering is correct as is shown on the slide. If you started numbering this alkyne, the base or the parent, going from the right, it would be 1, 2, 3, and of course it would still be a 3-hexyne, but the bromide would end up with the number 5. So in this case, you number it in such a way that you give the substituent the lowest possible number, and 2 is a lower number than 5. And thus the correct name would be 2-bromo-3-hexyne.